Hello, this is Alex from cables.gl. I want to quickly show you how to set up a 3D navigation menu type of thing with the new AmmoWorld and AmmoRaycast operators, and then maybe show you a little bit about this Ammo debug renderer that's really helpful. But yeah, I have a patch here that's set up to allow me to do this. So I'm using my mouse to rotate, and then when I mouse over the different 3D cubes, they will move up and down. And it's really nice because it's quite precise that, they all move when they should. And if I show you this debug renderer and maybe remove the materials, here you go, here you go. You see this green bounding box and some sort of directional axis things on here. And then when I mouse over this green box, then an animation plays. And if I actually turn on this flow here and focus on this first cube on top, you'll see that there's a little trigger that happens. A Boolean gets flipped when I mouse over, and it triggers a bool animation animator operator, and then changes the transform of the 3D model. And we'll get into why I did it this way, because I used to do it another way. And then you get into kind of UI interface issues that are very common with computers and mice and interactivity and the web and all that stuff. So what should we do? We should probably start from scratch, right? And then continue with exploring all the intricacies of the stuff. So let me just disconnect this, and then I'll move over the main loop and then start from scratch. So let's say we're working on a menu and we want it to be in 3D space. Maybe it's going to be in 2D space, but we want this geometry to be our buttons, right? I like cubes, and they're going to be my buttons. So I'm going to put down a cube, and then I'm going to scale it. Actually, I'm not going to scale it. What I'm going to do is start this AmmoWorld in my project. So now I have this AmmoWorld, and my physics objects will start to live in it. If you look over the parameters, there's some gravity and a simulation tick box, and reset and activate. Pretty basic stuff. The gravity we don't really need, because I want to make this menu kind of a traditional website menu sort of thing. So it's just going to be flying in space, basically, and not moving other than reacting to my mouse over. And then the reset's pretty handy. I'll probably use that a bit. And simulate, yes, we want that. And activate all, well, I guess it's already activated. It has its own use cases, but for this menu project, I don't think we need to worry about it. So next, we need the AmmoRaycast operator. And if you've seen the previous Raycast tutorial I've done last year, when we used to use a different physics setup, but quite similar one, actually, it's, I think, even faster to set up. But the concept is pretty much the same. We're shooting out lasers from our mouse coordinate to a physics object, which has a bounding box, and if our laser hits it, then we get a report that, yeah, we hit something. So let's take a look at this AmmoRaycast operator, and we have some inputs for our mouse coordinates, or maybe some other values that you will feed into it. Maybe there's a tracker that you're using, or maybe one of the sweet new augmented reality operators. You can do that stuff, not just with a mouse. So then we have the active and change cursor inputs for flipping these tick boxes, so we can change the cursor when we mouse over a square or a cube or something, or not. And then we have some outputs, has hit and hit body name. So what this thing will do is tell us, yes, we hit something. And then when we need specific information of what we hit, then we'll get a string of the name of the object we hit. So right now we have this cube, and it's pretty much in the graphics world. It's not living in the physics world. What we need is actually, I'm going to remove this connection and put down this AmmoBody operator. It's very, very nice to use, very like very it has a lot of good parameters that we need. So we can just use it by itself. We don't need to modify it with other ones. It's a really, really well equipped operator, I should say. All right, so for mass, we don't need anything, right? Name, that looks important. Let's do that first. Cube. We're gonna name our AmmoBody cube. Then we have mass friction restitution. Love that word. That we don't need to deal with right now as well. But maybe in a future tutorial, or of course in a future tutorial, we'll get more into the actual physics as we know them, and have some things collide and ricochet off each other. So we'll use that then. But right now we don't need to worry about that. And then we have a shape, which is basically our bounding box cage. And right now we have box selected, but I can't see it. But as I mentioned before, we have this debug renderer operator, which is really handy. And I'm just going to disconnect it from that setup and move it over here. And it needs to live under the AmmoWorld. And now we see our cube, right? And if I change it to a sphere, then we have a sphere. And I'm going to put down an orbit controls and zoom out a bit and then rotate around this bounding box cage. So we have a cube. Let's actually change it to a cube again. Box. And what else do we have? We have a simplify max triangles parameter. That's more of for convex hull that we'll get into a little bit later in this tutorial as well. Then we have size, which is really interesting because we didn't have this earlier, and now we can actually transform the physics cage. And then we have this output on the bottom of the operator that has a transformed trigger output. So for example, if we connect it simply to the next trigger, we can see that our kind of graphics rendering of the cube doesn't match up our collision cage. And I hope you can see it. I hope so. It could be it could be quite small to see this cage. Sorry about that. It's this green pixel line. But it doesn't match the shape, right? So that's a problem. So for example, if I want to pick the cube, actually it's already active, right? So no, it's not active because we're not feeding anything into the AmmoRaycast. Let's quickly set this up and then I'll show you why it matters when the cage is the wrong size. Okay, so AmmoRaycast needs X and Y from our mouse, and we don't need the pixel values, which are what are reported by the mouse operator right now. We need 0 to 1. So we'll just normalize the mouse. And now when we mouse over the cage, you'll see my cursor changes, right? So back to why this way is kind of annoying, right? We have a cube and then we have this cube and they're different sizes. So then we need to like match the size to the graphics version of our cube that I will throw a material on. So this is kind of what we had to deal with before, but now all you have to do is plug it into the transformed output, and the geometry below the physics cage will be transformed to fit the cage, which is so nice. So if you're working with primitives like cones and spheres and boxes that you can also find in our typical cables geometry, simple geometry nodes. Then, for example, I'll put in a sphere and then change this to a sphere. And now I am changing the radius and my sphere changes as well, my kind of graphics version of the sphere. So super nice, right? Like so much time saved. I love it. So good. So that's neat too. Now we have a nice cage for our sphere, and when we're around the sphere, nothing is triggered. And then when we do mouse over the sphere, we get this report in our AmmoRaycast operator, and also on the AmmoBody, which is fantastic because in some cases you might want to check if the name was hit. So, for example, this string will show us that we hit a cube or nothing, right? It's now a sphere. Okay, so if we hit the sphere, it will tell us. And then we would have to do maybe like a check. Is what was reported by the AmmoRaycast a sphere? And if true, then maybe play the Boolean animation for maybe making the sphere bigger. So you can do that, and there might be good reasons to do that in the future or in your future project where you do need to quickly maybe check for a name from this AmmoRaycast operator. But for quite simple things like doing a menu, we can simply do a check inside the AmmoBody operator. It has an output of, was it hit by a ray? True. That's exactly what we need, right? So I'll put down maybe a Boolean animated animation, bool anim, and then I'll do the scaling again because I want to show you why it's sometimes nice to not scale your geometry hitbox. Okay, so we plug in our scale. Yes, scale into our bool anim. And instead of 0, we'll do 1. And then here, maybe a 2 or something. And then we'll plug in this to the next. Or it can even go in between, doesn't matter. To make it a bit neater, we'll just put it here. Right? So now when we mouse over, our sphere gets bigger, and we're closer to doing some cool interactive stuff. Now, what can you also do with this AmmoBody and AmmoSphere? That's amazing. Now we can actually use the transforms above the geometry object and move around this static geometry body into any position we want. And with that moves the cage, and of course the raycast result changes as well, or we're looking for the sphere in a different place in the screen. Super cool. You can animate this. It works perfectly. Fantastic. Now, if we change the scale, it doesn't work. So don't worry about that. The scale doesn't work. It's strictly for position of the object at the moment. So good stuff. Now, the scaling. If we scale our radius, right, and animate it as well. So let me do this. We'll do it like this into the radius and then remove this transform. Whoops, didn't want to do that. We'll remove this transform. And now our cage and the graphics rendering of the sphere will get larger when we mouse over. But you see, you get into this strange catch-22 where you're changing the size of your hitbox and also kind of the graphical representation of your button or sphere or something like that. So it's just kind of like a thing to watch out for when you are doing interactive menus and maybe some sort of panels inside a virtual room or something like that. Remember to keep in mind that you probably need to leave the mouse over or the interactive areas of your user interface completely alone. Otherwise, you're going to get into weird glitches where the hitbox is changing size and it's again checking if the ray has hit, and then you get like stuck basically. So wanted to do this mega tangent to just uh, get that point across. So you can change this, but sometimes it doesn't make sense to change it interactively, is what I'm trying to say. So, all right, now back to our original setup. So, don't need this anymore. We will hook up this pre-constructed menu and maybe connect all these basic materials as well. By the way, I kind of like this trick where you're using basic materials and then you just add in a Fresnel glow and then you get this kind of cool, unique material. Anyway, so we have our menu-like thing, and you see like when I also mouse over as I'm rotating the camera, it still animates. So you might need to do some cool logic where it's like, well, don't check for this if your button's already pressed. So you got to do some cool like logic checks that make sense to your user interface. And in our demo room that I talked about before, I think there's a few places where it does do some sort of checks, like don't activate this if you're rotating. I think here, if you look into the how this gallery is constructed, the user gallery, see when I mouse over, I don't trigger the web pages opening the projects that are being shown on these panels here. So you can do some sort of raycasting and checking that makes your user's life a lot easier and doesn't activate certain animations when they don't expect them. So yeah, we're basically doing the same thing as you see in this demo room. Feel free to copy it there and see how it's made. And we have it here as well. So we're just using cubes, and we pretty much made one setup like we just did with the sphere, and then copy pasted it and then transformed it to a different location, right? So pretty sweet. You just basically make one of these smart buttons and then change them, maybe put in another texture or put in like a text mesh 3D to give it a name. And yeah, you can do that with the simple meshes. But what happens if you have a GLTF scene, right? Can you do anything like raycasting and checks for mouse hits and stuff like that with GLTFs? Of course. So let's plug this in. And we got this peace sign, right? And let's see if we can actually show you the debug renderer result of what we're getting from this GLTF. And we need to reset our world so it forgets the physics objects that were plugged in before. And now you see that we have a GLTF with the geometry broken out. So I went into the show structure and then just kicked out one of these nodes, press node, and then I have this node with a geometry output. And then this geometry output, I plug into that same operator that we were just working with, the AmmoBody. And then for the shape, I select geometry convex hull. And now these parameters for the simplify max triangles start to matter because we can create a super, super simple cage for this peace sign, maybe with like 4 vertices. Okay, that's extremely small. Maybe like 12, right? And we get this approximate shape that the operator figures out. And this could be really handy sometimes when you for sure don't need a very high detailed hitbox and you want to save some resources, and maybe a shape like this is good enough for you. So this is where you change the number of triangles. So I had it at 64. Let me type it in, 64. And it looks pretty good. It matches my peace sign. And that's pretty much how you do the same thing with custom geometry. So you're not just stuck to using cubes and spheres and stuff like that. And if you remember our past um, physics engine, it didn't really do the cages in such a cool way. We didn't have a convex hull with a controllable amount of triangles. We basically had a box that would go around your object, and it would be not super cool when you're trying to pick an object that is behind like 10 other objects or something like that. Anyway, that's pretty much the basics of raycasting with Ammo. And I hope you stuck around and learned all these cool new tricks. And hopefully you feel that it is 10 times, if not 100 times better than the old way of doing things. And I'm really looking forward for you to try trying to make 3D navigation. And maybe then we also add some uh, velocity and physics and friction and collisions and stuff like that in a future tutorial. So thanks a lot. See you around. Come to our Discord. Come to the meetup. Bye.